Hello, today we'll understand how to do the pH calculations when the titration of a strong acid with a strong base is being carried out, and at the same time how to do a titration curve for this process and also understand it in detail. So we are taking up a question where we have a strong acid, which is hydrochloric acid, reacting with a strong base, which is NaOH. We are taking the volume of HCl being 50 ml. 50 ml means 0.05 liters. And the concentration of HCl, we are taking it as 0.1 moles per liter, which is molar. Now, we are going to do a step-by-step process. So the first part of it is when no NaOH is added to it. And at the same time, we'll be drawing the titration curve also for it simultaneously. So now if we haven't added any NaOH, we have only HCl whose concentration is 0.1 molar. And because HCl is a strong acid, it breaks down into H positive and Cl negative. So whatever is the concentration of HCl, the same is going to be the concentration of H positive and Cl negative because the ratio is 1:1. So we have the concentration of H positive as 0.1 moles per liter. And if we have H positive ions concentration, then we can use this in the formula pH is equal to negative log of H positive or H3O positive ion concentration. Here it's convenient for us to take H positive. So this is equal to negative log of 0.1 and this value is equal to 1. So the pH before adding any NaOH to 0.05 liters and concentration as 0.1 molar. So the pH of that solution is 1. So what we are going to do is, so when no NaOH is being added to it, we are just going to take the pH over here as 1. So this is our starting point on the graph. So now we are taking the second part where we are adding 25 ml of NaOH to HCl and the concentration of NaOH given to us is 0.1 molar. And now because the volume of NaOH added is 25 ml, so in liters it's going to be 0.025 liters. So now for calculating the pH of this solution, first we have to find the number of moles of each, the acid and the base. So the number of moles of HCl can be calculated by the volume multiplying by its concentration. So this is 0.05 multiplied by 0.1 and this gives us 0.005 moles. The same way we'll calculate the number of moles of the base, which is NaOH, which is again going to be its concentration times volume, and this gives us 0.025 being multiplied by 0.1. So this gives us a value of 0.0025. Now we can clearly see that the number of moles of NaOH is in less amount. So this is a limiting reagent. So the solution will have its pH depending on the excess reagent. So our excess reagent is HCl over here. So we'll first figure out the excess number of moles of HCl. So number of moles of HCl which is in excess because that's going to make the solution acidic. So excess moles of HCl is 0.005 and from that we'll subtract 0.0025 and for this we'll get 0.0025 moles. So these are the excess number of moles And now because we have added the two solutions together, so we have the total volume as 0.05 liters of HCl and 0.025 liters of NaOH, which means the total volume is 0.05 plus 0.025, and this gives us 0.075 liters. Now, the concentration of HCl, which is the new one, will be calculated as the excess number of moles divided by the total volume. So we have the 0.0025 moles, and that being divided by 0.075 liters of the solution. So the new concentration we have as 0.033 moles per liter. And because this is the new concentration of HCl, and again this HCl being a strong acid breaks down into H positive and Cl negative. So the concentration of H positive ions also is going to be 0.33 moles per liter, and this presence of H positive will make the solution acidic. So the pH will be equal to negative log of H positive ion concentration, which is negative log of 0.033, and we get this value as 1.48. So approximately it's 1.5. So this is the pH when we have added 25 ml of NaOH. So we'll go over here, and when 25 ml of NaOH is added, the pH is approximately 1.5. So we've made a mark over here, and now we'll proceed with our next part. Now we are adding 45 ml of the same concentration NaOH to the HCl, and we'll figure out the pH now in this situation. So now because we've added 45 ml of NaOH, so the volume of NaOH added is 0.045 liters. We'll again do the same process. The number of moles of HCl is equal to concentration, which is 0.1 multiplied by volume, 0.05. So this gives us the same number of moles, 0.005 moles. And now we are going to calculate the number of moles of NaOH. So the number of moles of NaOH is equal to the concentration, which is 0.1 molar, multiplied by volume, which is 0.045 liters. So our number of moles of NaOH are 0.0045 moles. Still, we can see that NaOH is the limiting reagent. So we'll find the number of moles of HCl which are in excess. So that we can obtain again by subtracting the 2 moles, which is 0.005. Subtract 0.0045. So this gives us 0.0005 moles. So these are the excess number of moles. Now again we'll find the total volume. So the total volume will be equal to the volume of HCl, which is 0.05, plus the volume of NaOH, which is 0.045 liters. So the total volume is 0.095 liters. Now we'll find the concentration of HCl, which is the new one, by taking the number of moles and dividing by the total volume. So we get 0.0005, that being divided by 0.095, and hence we get the new concentration as 0.00526. Now again, this is HCl, a strong acid, dissociates into H positive and Cl negative. So whatever is the concentration of HCl, the concentration of H positive is going to be the same due to the 1:1 ratio. So the concentration of H positive is 0.00526 moles per liter. And now we'll use this concentration in the pH formula. So pH is going to be equal to negative log of 0.00526. And this gives us 2.28, which is approximately 2.3. And let us have this. So the volume of NaOH is 45 ml, so we have it over here, and the pH is 2.3 approximately. So we have this over here, and those are our 3 points. Now let us see the next situation. For the next one, now we'll calculate the pH at the equivalence point. So what is the equivalence point? Equivalence point is a point when the number of moles of the acid is equal to the number of moles of the base. Because the volume and the concentration of HCl is given, so we'll find the number of moles of HCl, which is equal to 0.05 multiplied by 0.1, and this gives us 0.005 moles. So at equivalence point, the number of moles of the base also should be the same. So the number of moles of NaOH is equal to 0.005 moles, because we have calculated the number of moles at equivalence point, so we can get to know the volume now. So volume is going to be equal to the number of moles divided by the concentration. So the number of moles are 0.005 and concentration is 0.1. So we get the volume of NaOH used as 0.05 liters, which means at equivalence point 0.05 liters of NaOH has been used, which we'll write over here. And because HCl and NaOH react together to completion, there are no excess moles of any of these acid or base left out to make the solution acidic or basic, and they have neutralized one another completely. So the pH of this solution at this point is going to be equal to 7, which means when the volume of NaOH is 50 ml, the pH is 7. So we've made a mark over here. And now we are going to proceed to our next step. In this situation, now we have added 55 ml of NaOH, which means the volume of NaOH added is 0.055 liters. The number of moles of HCl remains the same, but now we'll calculate the number of moles of NaOH. So this is equal to the concentration, which is 0.1, multiplied by the volume, which is 0.055. So this gives us 0.0055 moles. Now we can see that our HCl is the limiting reagent because it has less moles, being in the ratio of 1:1. So now we'll find the number of moles of NaOH which are in excess, because now this NaOH is going to turn the final solution basic. So number of moles of NaOH is 0.0055 and subtracted 0.005. So this gives us 0.0005 moles. And now we have to calculate the total volume. So the total volume is 0.05 plus 0.055. So this is equal to 0.105 liters. Now we'll calculate the concentration of NaOH, which is the new one. So this is number of moles, 0.0005 moles. And that being divided by the total volume, which is 0.105 liters. So a new concentration of NaOH is 0.00476 moles per liter. Now this NaOH, being a strong base, it will dissociate completely into Na positive and OH negative, and everything being in the ratio of 1:1, whatever is the concentration of NaOH, the same will be the concentration of OH negative. So the concentration of OH negative is 0.00476. And now because we have OH negative ion, so we'll be able to calculate the POH, which is equal to negative log of hydroxide ion concentration, which is 0.00476. So this gives us the POH as 2.3. And now to calculate the pH, we have to do 14 minus 2.3. And this gives us a pH of 11.7. So we are going to have this marked on the graph. So when our volume is 55 ml, our pH is 11.7. So 55 and 11.7 is going to be somewhere over here. And now we are going to move into our last step and complete the titration curve. Now in this last part, the amount of NaOH which is added is 70 ml. So we have the volume of NaOH as 0.07 liters. The number of moles of HCl is still going to remain the same, but the number of moles of NaOH now is equal to concentration 0.1 multiplied by volume, which is 0.07. So this gives us the number of moles as 0.007 moles. Again, the number of moles of the base are more, and so we'll figure out the number of moles of NaOH which are in excess. So those are equal to the number of moles of the base, subtract the number of moles of the acid. So we get 0.002 moles of NaOH which are in excess. Now we'll find the total volume. So that's going to be 0.05 liters and 0.07 liters being added together. So this gives us 0.12 liters. Now we'll find the new concentration of NaOH, which is the number of moles of NaOH which are in excess, 0.002 divided by the total volume, 0.12. So this gives us 0.0167. And because it is again a strong base, breaking down into Na positive and OH negative. So the concentration of OH negative is still going to be 0.0167 moles per liter. Our POH is going to be equal to negative log of 0.0167. This gives us 1.8. And then pH is going to be equal to 14 minus 1.8, which gives us 12.2. So when 70 ml of NaOH is added, our pH is 12.2, so somewhere over here. And now with these points, we can draw a titration curve. We are just going to join these points smoothly. So that's our titration curve. I hope you understood the process. See you in the next one. Bye-bye.